Natural gas has enormous potential as a versatile energy source. While it's had a history of powering electric generators and heating stovetops, it's growing in use as an efficient fuel that also powers cars and trucks. But what exactly is natural gas? Natural gas is a naturally occurring chemical, primarily made up of methane, CH4. Its purity makes it an environmentally friendly fuel. Methane does not leave a residue when burned, so its emissions do not react with sunlight to create smog. The natural gas we use today began as microscopic plants and animals living in the ocean tens of millions of years ago. As they thrived, they absorbed energy from the sun, which was stored as carbon molecules in their bodies. When they died, they sank to the bottom of the sea and were covered by layer after layer of sediment. As these plants and animals became buried deeper in the earth over millions of years, heat and pressure began to rise. The amount of pressure and degree of heat transformed the biomatter into natural gas. After natural gas was formed, it tended to migrate upward through tiny pores and cracks in the surrounding rock. Some natural gas seeped to the surface, while other deposits traveled upward until they were trapped under impermeable layers of rock, such as shale or clay. These trapped deposits are where we find natural gas today.
So in nuclear fission, you have an atom that splits into two or more smaller pieces. This process of splitting can release a tremendous amount of energy. And nuclear fission provides the energy for things like nuclear submarines, nuclear power plants, and even nuclear bombs. So in nuclear fission, we can start with an atom like uranium-235. And uranium-235, it's pretty unstable. It's a pretty unhappy atom. To make this split, we try to aggravate it. And here's what we do. We take a neutron and we slam this neutron into the atom. I'm just showing the nucleus here. These are the protons and neutrons in red and blue. I'm not drawing the electrons because they're not really important for what we're doing here. So anyway, this uranium-235 atom gets this neutron and it holds on to it, which turns it into uranium-236 because it has one more neutron. Uranium-236 is super unstable. It is way more unstable than uranium-235 is. And in fact, it's so unstable, it's so unhappy, that it splits into two smaller atoms. Here are the nuclei right here. One of them is krypton-92, and the other is barium-141. Both krypton and barium are way more stable. They're both way more stable than either of these atoms that we started with. So we're going from unstable to stable, so energy can be released.
So why are fossil fuels such a powerful but ultimately problematic source of energy? Conditions on the waterways of today's Louisiana help us understand how fossil fuels are made and why they're ultimately unsustainable. Oil, coal, and natural gas are made from things, mostly plants, that lived and died long ago. It's taken hundreds of millions of years for nature to create enough of the special conditions that save the carbon and energy in plants to form the fossil fuels that we use. Here's how it works. Plants, like these tiny diatoms encased in silica shells, grow in the upper layers of lakes and oceans, using the sun's energy to turn carbon dioxide and water into more plants. When they die, if they're buried where there's little oxygen to break them down, Their chemical bonds retain the energy that began as sunlight. If enough carbon-rich matter is buried deeply enough, for long enough, the Earth's heat and pressure turn it into fossil fuel, concentrating the energy that once fed the growing plants. Vary what goes into Earth's pressure cooker and the temperature, and you end up with the different kinds of fossil fuel.
Woody plants make coal. Slimy plants, algae, will give you oil, and both of them give rise to natural gas. The fossil fuels formed over a few 100 million years, and we're burning them over a few 100 years. And if we keep doing that, sooner or later they must run out. But there's a bigger problem with fossil fuels. As we've seen, they're made of carbon primarily. When you burn them, you add oxygen, and that makes CO2 that goes in the air. We're reversing the process by which they formed. And if we keep doing this, it must change the composition of Earth's atmosphere.